Okay. Um, Good morning, guys. In this tutorial, we are just going to go through tutorial sheet 10, okay, of chemistry. And this tutorial sheet 10 of chemistry, it's just about chemical equilibrium, okay? So we are going to talk about chemical equilibrium and how to solve questions that involve this chemical equilibrium, okay? So we are going straight into it. All right, so the first question there, they're saying, write the expressions for K and Kp for the following reactions, okay? Write the expressions for K and Kp for the following reactions, okay? So you have to understand that in chemical equilibrium, when they just write K or they write Kc, it just means that you're talking about the equilibrium constant in terms of concentrations, okay? If it's K or it's Kc like that. And then if they say Kp, it simply means that they are talking about the equilibrium constant in terms of its pressure, okay? So the formulas on how to find these two, they're just the same, okay? So for Kc, it means that you have the concentration of products on top here, okay? You have the concentration on product on top there, divided by the concentration of our reactants. And then for Kp, it means that you have the pressure for the products on top, and then down there, you have the pressure for the reactant. As simple as that, okay? So I'll show you how I did it. So this is how I did it here, okay? So I was explaining that K is the equilibrium constant in terms of the concentration, and then the Kp is just the equilibrium constant in terms of the pressure, okay? So let's get our first reaction there. So always make sure that your reaction is balanced, okay? So if we get our first reaction there, we'll have this guy here, ammonia reacting with carbon dioxide to form this compound and water, okay? Then another thing that you have to note when you are calculating your equilibrium constant, or you want to find its expression, the species that will be in solid state, okay, is not included in the equilibrium value. Why? Because if something is solid, it is considered as having a less effect on the change of these quantities, okay? So whenever you see any compound here with a solid state like this one here, just know that that compound, we are not going to include it in our K or our Kp. All right, so let's find for this reaction, let's find our K, okay? So it is equals to concentration of products to the power n. That n there, it just simply means the coefficient in front of that product, okay? So for example, for water, the coefficient there is just 1. Even here, there's 1. For carbon dioxide, there's 1. And then for ammonia, there's 2, okay? So that n here represent those two coefficients like that, okay? And then down there, okay, you're dividing the concentration of the products on top and then the concentration of the reactants down there. You can also see that it has a Km, okay? So that Km represents the coefficient that will be in front of that reactant, okay? So on the product side in this reaction, what do we have, okay? We have water and this other product there, okay? We have water and that other product. We can see that this other product is in terms of a solid. So we won't include it in our expression. We'll just get the concentration of this water. No wonder here, just put the concentration of water. And then on our reactant side, what do we have? We have carbon monoxide and ammonia. And ammonia has a 2 in front there, okay? So it means if I write the concentration of ammonia, okay? So these brackets that are like this, they mean the concentration, okay? So concentration of ammonia, and then that K2 there that is in front, it becomes like a power like that, okay? So the 2 becomes like a power, and then the concentration of carbon dioxide here, which does not have any coefficient here, it's just 1. So meaning even here there's 1, but it's the same even if you don't write it, okay? So this is our Kp, and then our K, this is our K, or it can also be known as our Kc. And then our Kp now, it means we're just representing the same expression, but now in terms of pressure. Okay, so we are not going to use this symbol here, which is for concentration. For pressure, we're just going to use what? P, like what? Like that, H big P. Okay, so you can see H big P raised to a certain power, which are coefficients in front of these numbers. Okay, then you can put your products there. Then H big P to the power M, and then reactants. Okay, so on the reactants, on the product side there, we can see that we only have one, which is in gaseous form. This one is solid. We can't include it in the Kp. Okay, just the same as we did here. Okay, so we are going to get the partial pressure, not the partial pressure, I mean the pressure of this water. We're going to put it on top there. Okay, and then down there, we're going to put the pressure of ammonia and carbon dioxide. But remember that this ammonia here has a K2 in front. This is K2 you are seeing on top there. Okay, so you square the pressure and then you write the ammonia multiplied by the pressure for the carbon dioxide. That's how you express your Kp. Okay, and then going to do the same on this second reaction there. Okay, we can see that on the reactant side we have a solid, and then on the product side we have gases. Okay, so it means this guy, since it's solid, we won't include it in the Kp. Okay, so our Kp will just be equals to, remember our K or our Kp, okay, start with the product and then the reactants down. Even this one starts with the product and then the reactants down, okay? But on the side of reactants, we have nothing, okay? So we don't put zero, we just don't write anything there, okay? So on the product side, we have this. This is the concentration of the product. And then down here where we're supposed to write the reactants, we have nothing there. Why? Because this guy is in solid, okay? So it means this equilibrium constant here will only depend on the concentrations of these products there, okay? And then coming to express it in terms of pressure, it means just remove these two bars here that represent a concentration, then you put your pressure there, and then you put your pressure there. But remember that this pressure for this bromine here, okay, it has a 3 in front, meaning your pressure there should be raised to the power 3, just like this concentration was raised to the power 3, okay? Yeah, so we are done there. That's how you find your Kp, okay? Okay, moving on to question 2. Let's look at the question, okay? So question 2 here, they're saying the following equilibrium pressures at a certain temperature were observed for the following reaction, okay? So they have given us that reaction. Always check if it's balanced, okay? In this case, this is balanced. And then they've given us the pressures. They've given us the pressure of this guy here, which is 0.55, the pressure of NO, which is that, and then the pressure of O2, which is that, okay? And what's the question now? They're saying calculate the value of the equilibrium constant, Kp, okay? So here we're not just expressing it, but we are calculating it because we have been given what? The actual values, okay? So it means, where are my solutions, okay? So it means this is the reaction there, right? Okay, so we know that when we write the Kp expression here to just be in terms of pressure, right? Okay, to be H big P here raised to the power 2. Here there's a K2 here. I'm sure you can see it, right? Okay, raised to the power 2 because I have a K2 there. Then the concentration of this guy, okay, multiplied by the pressure of that guy, which is that, okay? And then it will be over the pressure of that guy, okay? With a K2 there, the pressure should have a K2 because there I have a K2, right? Okay, then now I'm just going to substitute these values that have been given there, okay? So where there's NO, the pressure of it, I replace it and I square it because I have a square there. And then here I just put the pressure of oxygen, and then down there I put the pressure of nitrogen oxide, right? It has like a square, so I square it. And then you simply punch this into the calculator step by step, and you should come up with that answer there, okay? Amazing. Let's go to number 3. So number 3, what does it state? Number 3 states for the reaction, we have water there, which is separating into hydrogen and oxygen, okay? Of course, the reaction is balanced there. Then they're saying this reaction has a K value of this at a given temperature, okay? And then they're saying at equilibrium, in a 2-liter container, okay, it was found that the water had this molarity, which is the concentration, right, guys? And then the hydrogen has that molarity, which is also the concentration, okay? And then here they're saying, the question, calculate the moles of oxygen present under these conditions, okay? So you see here that for you to calculate the moles of oxygen, you first have to calculate the what? The molarity of oxygen, or simply the concentration, okay? And we can get this concentration of this oxygen by simply applying that formula for K, okay? We know that K is equals to concentration of products over concentration of reactants, right? Okay, so using this formula, we're going to find the concentration of this oxygen, or the molarity. And then once we have the molarity, we're going to combine it with that volume there, which is a 2.0, because they are saying at equilibrium in a 2.0 liter container, which means the 2.0 is our volume, okay? So when I go here, number 3, okay, so I was even writing, I was saying here we calculate the concentration of the oxygen first and then its moles. Okay, so this is the reaction there. If I get my Kp expression there, it will be that. By now I know, we all know how I'm getting this, okay? It's just that squared and then this and then divided by that squared, because we have a 2 there and then we have a 2 there. That's why we're squaring there, okay? Then in that question, we've been given the value of this K. So I'm just going to replace the value of K is equals to the value of the concentration of hydrogen squared. And then we don't know the value of the concentration of this oxygen, but we know the value of the concentration of water squared there. I'm going to substitute, okay? Then here I'm going to put over 1 and simply cross multiply like that, okay? So this guy here multiplies with that 1. And it becomes that. And then that guy there on top multiplies with the 0.11 squared, okay? So for me to get just the concentration of this oxygen, I'm going to divide by this number both sides, right? So I divide this number, it disappears here. Then I divide there, it's appearing like that. Okay, then what next? Okay, what's next? Okay, so this number here has changed because here I squared it on the calculator. So you square this, you're going to get this, okay? Oh, no. What was I saying? We cross multiplied, no wonder the values have changed. This has gone with that and then divided by that. All right, I almost got confused. Yeah, and then this is the expression that you have. Then when you punch this on your calculator step by step, you're going to get your concentration of the oxygen as that, okay? Now, since we have the concentration of the oxygen, or the molarity, okay? And then the question we've been given the volume to be 2.0 liters, okay? You can use this volume and this molarity to find the moles. Okay, so this is what I did here. You have the volume there, and then you have the concentration. And then what are your moles there? I was asking, okay? So we know that concentration or molarity is just equals to moles over volume. And now I want to find my moles. It means my moles come there, and then I'm multiplying my concentration with my volume, okay? So you put the value of the concentration, value of the volume, and then when you punch on your calculator, you should be able to find this value there. Okay, that's number 3. We are done. Then we go to number 4. What's the question on number 4? Okay, this is the last question in this tutorial sheet for chemical equilibrium. So they are saying the reaction below is an industrially important reaction for the preparation of hydrogen. Okay, an equilibrium was established for the reaction at 500 degrees Celsius. Okay, then I've given us that reaction there. Okay, so when they give you a reaction, always make sure that it is balanced. So we can check this and we can confirm that it is indeed balanced. Okay, and then here the first question they are saying determine the change in N. Okay, what is the change in N? Change in N is just the change of moles. Okay, change of moles between the moles of the products compared to the moles of the reactants. Okay, so how do you get those moles? You just get the coefficient in front of each of those products or each of those reactants, I mean, okay? So this product here has a 1, that's our mole here, even there it has a 1, even there it has a 1, even there it has a 1, okay? So this change in mole is going to be equals to moles of product minus moles of what? Reactant. Okay, so moles of product, we're going to add 1 plus 1 there. Then I'm going to say minus moles of reactants, also of 1 plus 1. Remember, we're getting to my coefficients, so try. Okay, so this will just simply be 2 minus 2. And we can see that the change in moles there is just 0. Okay. All right, that's how you solve A. And then B, they're saying at equilibrium, the following concentrations were found in the reaction vessel. Okay, the carbon monoxide had that concentration, the water had that concentration, the carbon dioxide has that concentration, the hydrogen, they had that concentration. So now, what is the value of K for this reaction? Okay, but we know how to find K. We just divide the concentration of the products by the concentration of the reactant. Okay, so this is how we solve A there, I've explained. And then when I go to B there, I have this concentration. I just put them in the formula there, okay? The ones for the product on top, the ones for the reactants down. And then I substitute the values, punch into your calculator, get the value here, punch into your calculator, get the value. And then when you divide those values, they should be able to give you that answer, okay? Should be able to give you that. Okay, so this is it about the tutorial sheet for chemical equilibrium. Okay, so on chemical equilibrium, what I want you to note is this. Okay, one, you should know how to calculate the Kc value. Okay, which can just be written as K, and then you should know how to calculate the Kp value. Okay, which is a equilibrium constant in terms of pressure. Okay, so know how to calculate those two on chemical equilibrium, because that's what most of the equations are based on. Okay, they're based on Kc, Kp. Okay, and then you should know how to convert this Kp. Okay, in case you have been given just Kc, you should know how to convert the Kc into the Kp. Okay, so here you're going to write change in moles. Okay, and we know how to find this change in moles, right? Okay, we're just going to use this formula. Then you've been given the Kc there, you put it there to the power change in moles, you get your Kp there. Okay, I don't know if I've swapped them, but I think it's good the way it is, yeah. Okay, so Kp is equals to Kc to the power change of moles, and then the change of moles, you find them using this formula. So they can give you one, and then they ask you to find the other one. They can also give you Kp, and they tell you to find this Kc, okay? So you just do the opposite, okay? So you multiply by the reciprocal of this so that the power here disappears and it comes there, okay? So that's what I want you guys to note on chemical equilibrium. All right, so thank you very much. If you have any questions, my inbox is always free on questions to do with chemical equilibrium. Have a nice day.